In Linux, a file system is a method used to organize and store data on storage devices like hard drives or SSDs. It's a way of managing files and directories, specifying how data is stored, retrieved, and organized on the storage medium. The file system provides a structure that allows the operating system and users to interact with the data. Common Linux file systems include ext4, the default for many distributions, exFS, BTRFS, and more. Each file system has its own features and advantages. For example, ext4 is known for its reliability and backward compatibility with older ext file systems, while BTRFS offers advanced features like snapshots, checksums, and support for multiple devices. Understanding file systems is crucial for managing storage efficiently, optimizing performance, and ensuring data integrity. Linux allows you to choose the appropriate file system based on your specific needs and requirements. We'll now discuss the commonly used file systems. NTFS, which stands for New Technology File System, is a proprietary file system developed by Microsoft. It was introduced with the Windows NT operating system and has since become the default file system for Windows operating systems, including Windows XP, Windows 7, Windows 8, and Windows 10. We'll discuss about some key features and characteristics of NTFS. NTFS supports access control lists, or ACLs, allowing for fine-grained control over file and folder permissions. This enables administrators to define who can access, modify, or delete specific files and directories. NTFS provides built-in support for file compression to save disk space. It also supports file encryption through the Encrypting File System, or EFS, which allows users to encrypt individual files or directories for increased data security. NTFS supports very large files, up to 16 exabytes, and volumes, up to 256 terabytes. This makes it suitable for handling large amounts of data in both personal and enterprise environments. NTFS uses a journaling file system, which means that changes to the file system are first recorded in a journal before being committed to the main file system. This helps ensure file system consistency and recoverability in the event of a system crash or power failure. NTFS supports the use of Unicode characters in file and folder names, allowing for internationalization and the use of non-ASCII characters. NTFS supports sparse files, which are files that contain large blocks of zero data but only allocate space for non-zero data, helping to save disk space. It also supports hard links, allowing multiple directory entries to refer to the same file on disk. NTFS supports transactions, allowing multiple file operations to be grouped together as a single atomic transaction. This ensures that either all or none of the changes take effect, providing a level of data integrity. NTFS is well suited for a wide range of applications, from personal computers to enterprise-level servers, due to its advanced features and capabilities. While it is primarily used with Windows operating systems, there are also third-party drivers and tools that enable read-only or limited read and write access to NTFS partitions on non-Windows systems, such as Linux. FAT32, or File Allocation Table 32, is a file system that has been widely used across various computing platforms, especially in the context of removable storage devices like USB flash drives and SD cards. We'll now discuss about some of the key characteristics of FAT32. FAT32 is a widely supported file system that can be read and written to by various operating systems, including Windows, Mac OS, and many Linux distributions. This makes it a convenient choice for external storage devices that might be moved between different computers. FAT32 has limitations on both file size and partition size. A single file in a FAT32 system cannot exceed 4 gigabytes, and the maximum size of a FAT32 partition is 2 terabytes. This can be a limitation for users dealing with very large files or storage devices. FAT32 uses a simple structure based on a file allocation table, which keeps track of the clusters on the storage device and their allocation status. The simplicity of the file system makes it easy to implement and recover from errors. Unlike some other file systems, example NTFS or extension 4, FAT32 does not support journaling. Journaling is a technique used to improve file system reliability by recording changes to the file system in a journal before they are applied to the main file system. Without journaling, FAT32 may be more susceptible to data corruption in the event of a system crash or power failure. FAT32 has limited support for file and directory metadata. For example, it does not support file permissions or access control lists, ACLs, which are features found in more advanced file systems like NTFS. The cluster size in FAT32 is an important factor affecting file storage efficiency. Larger clusters can lead to more wasted space for small files, while smaller clusters can result in increased fragmentation. FAT32 is commonly used in removable storage devices due to its broad compatibility. Many devices, such as cameras, media players, and game consoles, use FAT32 for their external storage. While FAT32 has some limitations compared to more modern file systems, its simplicity and broad compatibility make it a popular choice for certain use cases, particularly when dealing with removable storage and when cross-platform compatibility is essential. exFAT, or Extended File Allocation Table, is a file system developed by Microsoft specifically designed for flash drives and external storage devices. It addresses some of the limitations of the older FAT32 file system, making it suitable for use in situations where large file sizes and portability across different operating systems are important. Here are key features of the exFAT file system. One of the significant improvements over FAT32 is that exFAT supports much larger file sizes and partition sizes. Individual files can be larger than 4 GB, and the maximum partition size is in the exabyte range, making it suitable for modern storage needs. Unlike FAT32, exFAT doesn't have the 4 GB file size limit, allowing for the storage of very large files, such as high-definition videos and large databases. It also doesn't have the 2 TB partition size limit, providing flexibility for large storage devices. exFAT is designed with flash memory storage in mind. It minimizes unnecessary writes to the storage medium, reducing wear and tear on flash-based devices like USB drives and SD cards. While exFAT is a proprietary Microsoft file system, it has been licensed to other companies, and support for exFAT is available on various operating systems, including Windows, Mac OS, and many Linux distributions. This makes it suitable for external storage devices that might be moved between different computers. Similar to FAT32, exFAT does not include journaling support. This means that it may be more susceptible to data corruption in the event of a sudden power loss or system crash. exFAT supports Unicode for file and directory names, allowing for internationalization and the use of non-ASCII characters in file names. The design of exFAT allows for faster file system operations compared to FAT32, making it more suitable for situations where performance is a consideration. exFAT is commonly used in scenarios where large files need to be stored on flash drives or external storage devices, and cross-platform compatibility is essential. However, users should be aware that exFAT is a proprietary file system, and some older operating systems or devices might not have native support for it. In such cases, additional software or drivers may be required for proper access. The ext4 file system, or fourth extended file system, is a widely used and default file system for many Linux distributions. It's the successor to ext3 and includes several improvements and new features. Here are key characteristics of the ext4 file system. Extension 4 is designed to be backward compatible with ext3 and ext2. This means that ext4 can be mounted as ext3 or ext2, allowing for a smooth upgrade process without immediately requiring changes to existing file systems. ext4 includes performance improvements over its predecessors. It uses a technique called delayed allocation to allocate disk blocks more efficiently, reducing fragmentation and improving write performance. ext4 supports larger individual file sizes and directory sizes compared to ext3. The maximum file size is 16 terabytes, and the maximum directory size is 2 terabytes. ext4 uses a feature called extents, which helps improve file allocation. Instead of using a linked list of blocks for each file, extents describe contiguous ranges of blocks. This reduces metadata overhead and enhances read and write performance. Like its predecessors, ext4 supports journaling, a feature that helps ensure the file system's integrity in case of system crashes or power failures. The journaling feature records changes to the file system in a log before committing them to the main file system. While ext4 aims to reduce fragmentation through delayed allocation and other techniques, it also supports online defragmentation. Tools like e4defrag can be used to defragment individual files or entire directories while the file system is mounted and in use. ext4 reserves a certain percentage of disk blocks for node allocation. This helps prevent file system fragmentation and ensures that there's space available for creating new files and directories. ext4 introduces the use of checksums at the file system level to enhance data integrity. This means that the file system can detect and potentially correct errors in data blocks, improving the reliability of stored data. The multi-block allocator in ext4 allows for more efficient allocation of multiple blocks at once, further improving file allocation performance. ext4 is commonly used in various Linux distributions, providing a reliable and feature-rich file system for a wide range of applications, from personal desktops to enterprise servers. It strikes a balance between compatibility with older ext file systems and the incorporation of modern features to meet the needs of contemporary computing environments. exFS, or exFile system, is a high-performance, scalable file system designed for Unix-like operating systems. Originally developed by Silicon Graphics, exFS has been integrated into many Linux distributions and is known for its efficiency in handling large amounts of data and high-performance requirements. Here are key characteristics of the exFS file system. exFS is designed with scalability in mind, making it well-suited for large storage systems and high-performance environments. It can efficiently handle large files, extensive directories, and massive storage capacities. exFS supports extremely large file sizes, with a maximum file size of 8 exabytes. 1 exabyte equals 1 billion gigabytes. The maximum volume size is also exceptionally large, making exFS suitable for enterprise-level storage solutions. exFS uses journaling to ensure file system consistency in the event of system crashes or power failures. The journaling feature records changes to the file system before committing them to the main file system, providing a way to recover the file system to a consistent state. exFS uses a dynamic node allocation scheme, allowing it to allocate nodes as needed rather than pre-allocating them during file system creation. This can result in more efficient use of disk space. exFS uses an extent-based file allocation scheme, similar to ext4. Instead of using a linked list of blocks, extents describe contiguous ranges of blocks. This helps reduce fragmentation and improves overall performance. exFS supports online resizing, allowing administrators to resize the file system while it is mounted and in use. This provides flexibility in managing storage without requiring unmounting or disrupting system operations. exFS includes support for snapshots, allowing users to create point-in-time copies of the file system. Snapshots can be useful for data backup, recovery, and other purposes. exFS includes the exFS_repair tool for checking and repairing the file system. It can handle many common file system issues and restore the file system to a consistent state. exFS supports sparse files, which are files that contain large blocks of zero data but only allocate space for non-zero data. This helps save disk space. exFS is commonly used in enterprise environments where large-scale storage, high-performance requirements, and reliability are crucial. It may be chosen for applications such as data centers, file servers, and database servers that demand robust file system performance and scalability. BTRFS, or B-tree file system, is a modern and feature-rich file system designed for Linux. It was created by Oracle and is now actively developed as an open-source project. BTRFS is intended to address the shortcomings of traditional file systems by incorporating advanced features. Here are key characteristics of the BTRFS file system. BTRFS uses a copy-on-write mechanism, which means that when data is written or modified, the changes are written to a new location rather than overwriting the existing data. This helps with data integrity and reduces the risk of data corruption. One of the standout features of BTRFS is its support for snapshots. Snapshots allow users to create point-in-time copies of the file system. These snapshots can be used for backup purposes or to revert the file system to a previous state. BTRFS introduces the concept of subvolumes, which are independent, mountable directory trees within the file system. Subvolumes can be used to organize data and create more manageable units within the file system. BTRFS includes support for RAID configurations, allowing users to create redundant storage configurations for improved data reliability and fault tolerance. This is particularly useful in storage environments where data integrity is critical. BTRFS supports online file system check and repair operations. This means that administrators can check and repair the file system without unmounting it, reducing downtime and improving system availability. BTRFS uses checksums to ensure data integrity. When data is written to the file system, a checksum is calculated and stored with the data. During read operations, BTRFS can verify the checksum to detect and potentially correct errors. BTRFS supports transparent compression, allowing data to be compressed on the fly to save disk space. This feature is particularly beneficial for environments with limited storage capacity. BTRFS supports online resizing, allowing administrators to resize the file system while it is mounted and in use. This provides flexibility in managing storage without requiring downtime. BTRFS can span multiple storage devices and provides features like RAID and device replacement, making it suitable for storage solutions requiring scalability and redundancy. BTRFS is often chosen for its advanced features, especially in scenarios where flexibility, scalability, and data integrity are critical. It is commonly used in production environments for both personal and enterprise-level applications. However, users should be aware that while BTRFS is stable and actively developed, it may not be as widely supported or considered as mature as some other file systems like ext4 in certain Linux distributions. ZFS, or Zettabyte File System, is an advanced and feature-rich file system developed by Sun Microsystems, now owned by Oracle. ZFS was designed to address various challenges in storage systems, providing features that enhance data integrity, scalability, and ease of management. Here are key characteristics of the ZFS file system. Similar to BTRFS, ZFS uses a copy-on-write mechanism. When data is written or modified, the changes are written to a new location rather than overwriting existing data. This helps maintain data integrity and provides protection against certain types of data corruption. ZFS integrates volume management and file system features into a single system. This means that tasks like RAID configuration, volume creation, and file system management are unified, simplifying storage administration. ZFS uses strong checksums to detect and correct errors in data. When data is read, the checksum is verified, allowing ZFS to identify and repair data corruption. This feature enhances data integrity, making ZFS suitable for critical data storage. ZFS supports efficient and space-saving snapshots, allowing users to create point-in-time copies of the file system. These snapshots are writable, enabling users to roll back to a previous state or clone snapshots for various purposes, such as testing and backup. ZFS includes built-in deduplication capabilities, which can identify and eliminate duplicate copies of data within the file system. This can be particularly beneficial for environments with repetitive data, such as virtual machine images. ZFS supports transparent compression, allowing data to be compressed on the fly. This can significantly reduce storage space requirements without sacrificing performance. ZFS performs regular data scrubbing to detect and correct errors proactively. During a scrub operation, ZFS reads all data and verifies checksums, helping to identify and repair any potential issues. ZFS introduces the concept of RAID-Z, a data protection mechanism similar to RAID but specifically designed for ZFS. RAID-Z provides both redundancy and improved storage efficiency. ZFS uses dynamic striping, which means that data is striped across multiple disks in a dynamic and adaptive manner. This helps balance performance and storage capacity. ZFS supports data encryption, allowing users to encrypt data on a per-dataset basis. This enhances data security in scenarios where confidentiality is a priority. ZFS is commonly used in environments where data integrity, scalability, and advanced storage features are critical, such as data centers, file servers, and storage appliances. It is often favored for its robustness, ease of use, and ability to handle large amounts of data efficiently. While ZFS is native to some operating systems like Oracle Solaris, it can also be used on various Linux distributions through third-party implementations. That's it for today. Please share this video if you find this content helpful. Subscribe to this channel if you would like to see more contents like this in future. And as always, stay strong.